So hi, the first thing is, the only time I'm ever referred to as Dr. Alan Schoenfeld is when I'm introduced in talks. I'm Alan. Second, I know who does the hard work, and it's not the person standing up here. The advantage of being an academic is that I can choose the hours that I work. So when my daughter was in school, I used to volunteer to work in her classrooms. And I remember in first grade, her teacher put me in charge of one little math station. And within about 45 seconds, all of the kids wandered away. And the next week I was a little better, and by the third week I actually got them to stay and talk math. And I said to the teacher, hey, I think I'm getting there. She said, you want to take over the class? No. So, I love school as a beginner. My goal has always been understand enough so that I can help the people who are doing the hard work, help our kids love what they're learning and get good at it. So that's the game. And that's the name of the work, Teaching for Robust Understanding. It goes by TRUE. And the goal is to build classrooms from which kids emerge as powerful thinkers, problem solvers, with productive identities. I can do this stuff and all that. So here are the two questions that I'm going to work on today. I do recognize it's 4 o'clock. There's lots of stuff going on, so I too appreciate your being here. In compensation for listening to me, you'll see 3, maybe 4 classroom videos. I'm sorry I don't have popcorn, but in any case, first question is, if you could name 5 things that would make a difference, if these 5 things went right, then kids would really learn a lot. What would those 5 things be? And then once we settle on those 5 things, how do we make them realities? Okay. Now, that was question 1. I'm tired of talking. Name some things. What's important? What do you want to have happen? Yeah?
The students must be engaged.
Okay, kids should be engaged. Yeah?
Students care about the learning, not about the grade.
Wouldn't that be nice? Kids care about their learning. Yeah?
Ownership.
Okay. You want to say more about that means?
Just that their actions are pivotal to the process.
They're not passive victims. Okay, they're in the learning for themselves, and one of the most common pronoun in math class is they. They said to do it this way, as opposed to I got this. That's ownership in part. Okay, yeah, yes.
The teacher needs to be engaged. Teacher needs to be excited about what they're teaching, and a role model for resourceful thinking and problem solving.
Everybody hear that? Okay. Now my students have seen me sit cross-legged on the desk and say, I can outweight you. Is that it? Do they do it? Yeah.
I have to read the question to make sure I'm answering this. They are able to answer problems that they haven't seen before. So they can take what it is that they learned and apply it to something related and new-ish, and be able to think their way through it, meaning they can figure out how to learn what it is. They can figure out what it is they don't know, and then figure out the parts that they don't know.
Okay, so I heard at least 2 parts to that. The first is what they're to learn is more than regurgitating what's been crammed down their throats, that they're actually generative. And the second is that they reflect on their own thinking and learning and get better at it. Yeah.
I'm just looking at the way the question is worded, and I feel like they would probably need to feel safe to take some risks. Like if they're going, and safe to like make a mistake and try it again, we want them to come out as good problem solvers.
Right. Classroom environment needs to be safe, because how are they going to learn to take risks and engage in the kind of problem solving if they're chastised for mistakes, among other things? Yeah. Yes.
I think resilience.
Resilience?
Resilience,
Yeah.
so that the ability to try things over and over again, and also not to give up very easily, because sometimes I find that kids are just, if they don't get it the first time, they.
Resilience, perseverance. Yes.
Clarity of what they're learning.
Okay. Saw some heads nodding. Yeah.
I don't quite know how to say this, and you did a great job rephrasing the last one, but somehow, and this comes back to, I think, being safe, somehow there's equity in the way things are explained, or the expectation, and that there's some, we talk about different access points for people, but not only different mathematical access points for people, but different social access points for people, so that when you're in the classroom, there isn't a defined pecking order of who knows what or who's better based on whatever there is. There's some sort of, I'm really bad with the words right now, but there's some sort of way to, where when you walk into the classroom, you don't feel as if your fate's already been set based on who you are or what you bring. It has nothing to do with that.
Yeah. There has to be a meaningful way into the content for every student, and every student needs to participate
That's it right there.
in ways that are productive. Okay? Yeah.
I think they need to experience an agency as learners, like that they have, that they within themselves can have efficacy around their ability to explore ideas.
Yeah, and agency is related to the ownership that we talked about before. I can do this. You give me something, and I'm willing to sit down and give it a shot. Okay. Yes.
You just said something that sparked something in me. In the agency and ownership that you were talking about, you said, give me something and I can do this. And I think that we need to tilt it and say, what do you want to do with the skill you learned? How can you apply the skill you learned? So I think that identity piece of it, of how they start telling us how they're going to be able to use it.
Thank you. That's a nice correction. Agency involves basically taking ownership of your own learning and pushing things forward. Okay. Yes.
They need to be comfortable not knowing. So
Right.
it kind of ties in with the safe classroom, but they have to be comfortable making mistakes and asking questions. It's an environment that encourages questioning and asking questions.
You mean people don't always get it right the first time?
I'm sorry to say.
I wish I could remember the Einstein quote verbatim, but it's about he was one of the world's best people at making mistakes. So if we went on, especially if I'd done a think, pair, share, we could have generated a lot more. Okay, we could make a nice long list. Now the challenge is, suppose we had the perfect list, and I've had groups generate 30, 40 such things. What do you do with a list of 30 or 40 such things? You put it in your back pocket or a loose leaf binder, and you never use it because it's too much, it's too complicated. So the reason I said 5 is you can handle 5. Okay. And what I want is some practical stuff that people can keep in mind and use in a continuous way to make a difference. So the question is, if I pick 5 things, what properties should they have? Well, the first is they really ought to cover everything. If I say, here here are 5 magic keys for improving teaching, and there's a number 6 that can kill you, then I haven't done my job. Those 5 better be it. And I want them to be useful because I want to be able to work on them with you, okay? So that's the game, and that's what I'm about to tell you about. My students and I suffered so much for 6 years. Talk about making mistakes on the way to coming up with something. I could tell you all about them, but I'm not gonna. Okay. Instead, what I'm going to do is I'm going to show you 3 videos. We'll talk about what you see in them, and then the categories we're going to emerge with will be the things we'll wind up using. So, just to tell you what I did do, I live at the university, so I have to read 18,000 papers a day, and there are 97 million on this topic. So I read them all and then said, well, there's this giant mess. Can I organize it down into something coherent? And the answer was yes. But I'd rather engage in the stuff ourselves and see what you come up with when we do it. One thing is very important about looking at videos, and that is, especially if you've taught for a while, it's so easy to see all the things the teacher in the video did wrong because you know how to do it right. Having been on the other side of that, I know what a horrible feeling it is to have people look at videos that way. I truly believe that every single teacher is doing what he or she does in the classroom in the best interests of his or her students as that teacher understands it. Now, that may not be what you would do. And I had a very interesting experience a number of years ago where I was working in the classroom of a teacher who was very, very procedural. Step 1, you do this. Step 2, you do this. Step 3, you do that. And I said to him one day, I'm just curious. Have you ever thought about just taking a problem and throwing it at the students and seeing what they do? And his response was, not these kids, it would just confuse them. I do that with my honors students. Now that opened up an interesting dialogue. He was doing what he thought was best for his students. And unless we talked about what was best for his students and what the consequences were, we weren't going to get very far. But the point is, it wasn't, I don't like what he's doing and I'm going to tell him to do it differently. It's, he had his students' best interests in mind. And I really believe that about teaching. So assume positive intent, try to make sense of what you're seeing, and imagine yourself on the other end whenever you look at a video. But let's push until we've made sense of what we see. I'm curious, because this is quickly becoming ancient history. How many of you have seen or know about the TIMSS study? Oh, okay. There are some ancient people here. That was the original horse race in which the United States was in the middle of the pack. And George H.W. Bush said, we will be first in the world by 2000. Oops. And then there was the video study in which Jim Stigler and Jim Hebert got millions upon millions of frequent flyer miles going to Germany, Japan, and around the US looking at practice. And they put out some videos. This is a typical US geometry lesson from the time. It was around 1990. The lesson is basically the teacher had these pictures on the board and the students were supposed to figure out what the angles were. The thing to do as you watch the video is imagine yourself a student in that class. What does it feel like to be in a class where this is the kind of instruction you're getting?
Vertical angles. What is the angle that is vertical to the 70-degree angle? Vertical angles are formed by what, Juan?
I'm just stretching.
Don't get nervous. You're just stretching. When I intersect lines, I get vertical angles, right? Look at your definitions. I gave them to you. You have them there. You can look them up. Here we have vertical angles and supplementary angles. Angle A is vertical to which angle? Therefore, angle A must be 70 degrees. Go from there. Now you have supplementary angles, don't you? What angle is supplementary to angle B? Angle A. B is, and so is C. Supplementary angles add up to what number? 180 degrees. So if you know one is 70, the other one has to be 110. Go from there. Okay, you have all your information. So we already figured these out. We have the measure of angle A is 70 degrees, B is 110, and C is 110. We know that. What information are we given in the second problem for D? Okay, two things. You have 53 degrees. What is the other angle I've indicated in there? Mike? It's a right angle, which adds up to 90 degrees, okay? What's left? Somebody just gave me the answer. 37 degrees, right? Why 37 degrees, Jamie? Carrie? 37 and 53 equals 90. The middle angle is 90. And why do they all have to add up to 180? Because it's a, Veronica? What is this angle called here? Straight angle. And a straight angle adds up to 180. Okay, you think in a couple of minutes you can figure out the rest of them?
Okay, that's video number 1. Take a minute or so and talk to someone nearby. We were going to be at tables where this would be easier, but imagine the world from the point of view of the student. What's the experience that you have of this instruction? You're almost as good as my kindergarten class. That's pretty good. Thank you. Okay, we'll have a chance to go public with all of these comments after we've watched the other 2 videos. So let me prep you for the second. How many of you know Joe Bowler? Okay. How many of you know Kathy Humphreys? Okay. They put out a book called Connecting Mathematical Ideas, and I've taken the video from that. One of the saddest things in my life was that Kathy was going to come to Berkeley to be a graduate student, but she decided she couldn't handle the commute. So she went to the farm instead, but such is life. In any case, here's the question she's going to be having her class discuss. I'm going to show you a 10 by 10 grid and put down pencils. You can do this mentally. I want you to tell me how many border squares are colored in. So that's the exterior of a 10 by 10 grid.
So what I've got right here is a 10 by 10 grid. And what I'd like you to do mentally is figure out, without counting one by one, how many squares are in the colored in portion. How many unit squares? And without talking, without counting one by one, without writing. Wow, lots of people have an idea. Would you talk to each other just about what you got?
Does that make sense?
Can I please have your attention back. Who has, by the way, what do we all want to say the answer? What is it? 36 squares, good. Did anybody think it was maybe 40 first? First? Okay, did anyone think it was maybe 38 first? A few people, okay. And so when you talked it over in your group, those of you who thought 40, what were you thinking? All right, Stephanie, what were you thinking?
I was thinking that one side is 10 and then there's 4 sides, so you multiply 10 by 4 is 40.
Okay, how many were thinking just like Stephanie? All right, what about the 38 people? What were you thinking?
I was thinking that the top 2 are 10, and so 10 plus 10 equals 20, and then the other 2 were 9 each, so that together they made 18. And together plus 18 equals 20.
Okay, all right. So now let's just see some different methods. You know how we like to gather different methods. So let's see some different methods for getting the 36. So let's see. Let's have Charmaine. Charmaine, what's your method?
Well, first I started out with 40 from 10 times 4, and then I subtracted 4 from that because there would be 4 squares overlapping, and so that got 36.
Raise your hand if you understand how Charmaine did it. And the 4 was for?
The 4 squares that overlap.
Okay, and this 4 was for?
4 sides.
And this 10 was for?
10 squares on each side.
Okay, another way to do it? Colin.
Alright, how I did it was I just put one side was obviously going to be 10, so it was 10, and then I did like the bottom one, and that was
Could you
going
go up and show us? I think that might help us.
So use like a pointer thing or just a pen.
The pointer's in the top drawer if you want to use it. Top, right in the center. There it is.
Alright, I found it. Anyway, so like I know this side's 10, so I just did like 10. And then this one's the overlapping one. So then this would be 9. Then this one would be 9 too, because this one's overlapping. And then for this one it'd be 8, because these two, this one was being used by this one, and this one was being used by that one.
Colin, I really liked the way you showed visually what you did. How many understood Colin's method? Wow, great. Okay, thank you. How about a different method? Wow, there's a lot. All right, let's see. Gee, it's hard to choose. Joe.
I added the top.
Want to go up like Colin did?
Okay. I know that this one, this is 10 and so is that. So I added those two. And at first I thought this was like 9 right there until I thought about it for a while. And that's 8. And so I added those two and that's 16 and then I added it to 20.
So Joseph, look at this and tell me if you think that represents what you did.
Yeah.
Okay, and the 10 and the 10 stand for?
This one and this row right here. How many blocks are in that row and how many into that one?
Okay, how many unit squares are in the top and how many are in the bottom? And then where'd you get the 8?
From like this row, except it didn't have these two. So
How many understand Joseph's method? All right, are there any other methods? Oh, lots of people, but how many had Joe's method that they wanted to explain? A lot of people. Can anybody think of another way to do it? Melissa?
Okay, since the whole square is 100 units, because 10 times 10, there's, okay, that, and then there's 8 that, there's 8 by 8 that aren't shaded, it's about 64, and you subtract 64 from 100.
And you got 36.
Yeah.
What do you think of that method?
Good.
Okay, so that would be, so Melissa though, help me though, you got 10 times 10 first,
Yeah.
and then you subtracted 8 times 8.
Oh, I get it.
Okay.
Later on, she'll have them do it with a 6 by 6 and then an n by n and say, shouldn't they all give the same answer? Which is when the math starts to get interesting. Okay, your turn. Okay, we'll watch one more and then we'll talk about them collectively. And this one needs a little setup. It's an inner city Chicago class where a substantial percentage of the kids are second language and or free and reduced lunch. The kids are working on one of the formative assessment lessons put together by the mathematics assessment project. I'll say a little bit more about them later, but for now I'll just introduce the task, which is they start out with 9 cards, 8 of which have either a decimal or a percent on them. And their job is to fill in the other one. So if it's 0.2, you figure out that's 20%. If it's 80%, you figure out that's 0.8, etc. And then the more challenging part, put them in order. Now, the reason that's challenging in part is that a very large percentage of 4th, 5th, 6th, 7th, 8th, 9th, etc. graders will tell you that 0.375 is larger than 0.75 because 375 is larger than 75. And that gets you into all sorts of arguments. So their job is to sort this out at their table. Then, having done that, we say, well, you did that with those numbers. How about area models? Same thing. Match the area models in terms of size. Then, we're not done. How about fractions? And how about number lines? And justify them and make sure you as a group agree. Okay. It's a challenging task. Okay. That's what the answers look like. The gray ones are cards that were missing. So you see the one with 0.6 and 60%. That was the 9th card. They had to figure out later on when they got an area model of 6/10 which one was missing. So a lot of stuff going on. Now let me presage the argument that's going to happen. If you look at the very last column, 125%, that's 1 1/4. One of the students is, so they got to make up a card for it. The gray one indicates there's something missing. One student at a table makes a 5 by 5 grid and fills it all in and says that's 125%. Each one of those things is 5, and 5 times 25 is 125%. And he gets into an argument with one of the other students. And you'll see what happens.
I don't know how many of you, well, everyone should remember this worksheet that we did that was fractions, decimals, and percents. Okay, and remember I said this was more of a pre-assessment to see what you know already and what we still need to work on. So based on what you did on this worksheet, we're going to do an activity today where you're going to be working with your partner most of the time. Okay? There are going to be times where you're going to work with your group, and I'll let you know when those times are. All right, so right now everyone's getting a worksheet. Once you and your partner have sorted your cards, so you're filling in the blanks first, then you're sorting them from left to right. That's why I don't want anything else on your desk, so you have space. Once you've sorted them, then you're going to turn and talk to your group members to check and challenge your explanation if they disagree. And remember, you have your sentence starters that you can use, and they're in your notebook as well, to challenge or each other's explanations or check for understanding.
So for 50%, to change it into a decimal, you need to put the 0 because it's not a whole yet, because it's at 50, it's at half, because the percent sign equals out of 100. So now the tens place would equal 50 because 10 times 5 equals 50. So now it's a decimal, so it's tens. So, and if you wanted to add a 0, it would be a fine, so it could be more easier to understand, and it would be a 50.
Get it?
I want to challenge Kashanda on 80%. I think it's wrong.
You gotta say I disagree.
I disagree. I disagree with you. I disagree with you. Let me do it for you. I disagree with you, Kishanda, because 80% does not equal 0.08%. As a percent.
I disagree with you. Can you please clarify how did you get it?
Can you clarify how you did it?
So if you put 0.5, it means that you're practically saying that it's 50%. So change it to 5. Change it to just plain 5%. So Kevin, do you know why she changed it to 5%?
Yes, because I was the only one doing it.
No, but like, do you understand why did she say to change it into 5%?
Yes.
Why?
Because 50%. Oh no, 5% would just be like just one, and if you put decimal, it goes to 50%.
Yeah. Okay, so let's go. We put next 12.5%.
Same thing, right?
Okay. So then
She put this one.
let's scoot this and put that there. Okay.
So I think I know how you got 1 and 1/4 because what you did was 1 whole because of the 1, and then when you did 1/4 because of the 25, which is 1/4 because 25 times 4 equals 100. Well, you can kind of get the idea of quarters, and then that's how you got 125% and 1 1/4.
Yeah, that's right. And then we got like 12.5% over here because it's 1/8. 1/2 equals 50%, and then to get 1/4 you have to divide that, which equals 25%, and then you have to divide that to get 1/8, and 25 divided by half, 2 equals 12.5%, and over here it's 3/8. Well, I already explained that 1/8 equals 12.5%, and 12.5% times 3 equals let me see, 37.5%, which is right. So 3/8 equals 37.5%. I know that you got 125% for 1.25, and that is right. That 1 point. That is right. That 1 and equals 125%, but your problem is the picture. You just shaded like this whole thing, and this, and even if it's not even a whole because you're missing this part, and like
I'm not missing any part. It's not like it's
yeah,
supposed
but
to be
it's not
full.
1 and it's not 125% equals 1 1/4.
No,
and
it's
this is
not
one
supposed to be 1 1/4. It's actually most likely all these squares it just equals 5 in each square.
How do you know?
Yeah, because if you would actually like if you would do like 5, 10, and it would all go to 125. Now I would like to see what you done.
I'm gonna challenge you. What does 1 equal? 1 equals what percent? 1, the number 1. 100. What's greater, 125% or 1%? Or 100%? 125%?
125.
So doesn't that means that since 125% is greater, doesn't that means that 125% is more than 1?
Yes.
Tell me if this answer is right or wrong.
It's right.
Why is it right?
It's right because if it does wouldn't. Oh wait, so now, actually I think I know where you're going with this. The fraction for this would be
1 1/4. That's where I'm going.
Why didn't you let me see it?
Sorry.
Chat with each other and then we'll chat. Okay, it's time to share out. Feel free to make a comment respectfully about any individual tape, about comparisons between tapes, focusing again on the student experience as much as you can. Floor is open. Yeah.
Oh, I just thought it was interesting, and I'm sure you did this on purpose, the progression between the 3 videos, kind of from the 90s to what we're doing now, where it was mostly teacher-led and then going all the way down to student-led in that last one.
By the time I've got 2-3 words written, you'll go, oh, he's a university professor, he can't write. So there was definitely a progression from teacher-led to, did you say student-led in the last one? Yeah. Okay. And that is a progression. Again, would that it were more prominent and widespread today than we saw on that tape. But we have moved from, the Tim's tape was generic US practice. You know, that's what I grew up with. And yeah, to a much greater role for the student. And you know, if you go back to the early comments that we had, that was one of the things about students taking on their own learning and explaining. Okay, someone else? Yeah.
In the last one, it involved other learning skills like negotiation and patience and standing up for yourself and defending a point. So it makes me think about how students can, they have an opportunity to show skills other than just math skills to feel successful.
Math is more than just the procedures that are laid out for you. Math involves engaging in all sorts of thinking, give and take, and so on. Yeah.
For the third video, we're talking about that the students had so much buy-in, but not just for the content, for making sure each other understood it. So they were really invested in making sure that everyone in their group had a clear understanding of it, and kind of like as a teacher to build that kind of culture in your classroom.
So there was a general buy-in, mutual responsibility. For each other's learning. King? Yeah.
In the first video, the teacher wrote an answer column on the board, so the emphasis on the answer was so great, where the next 2 videos, the teacher asked not, did you get the same thing as that person? They said, did you know how they got that? And then in the third video, the students were saying, can you clarify that for me?
Yeah, so what's the nature of the mathematical enterprise is an interesting question. Is it getting essentially known answers and just being able to reproduce, or is it sorting through stuff and being able to understand and explain? Yeah.
Just building on that, just in the final video, just like the discourse between the students, like the way they were talking to each other was like, sounded very like academic, professional, and respectful of all the group members.
Okay. Another one.
Sorry,
Quick.
another thing. What I also wanted to say about the discourse too is that like it wasn't just it wasn't the teacher pushing the kids to like think more deeply about it. I think we mentioned that the responsibility piece, it wasn't just like did they learn it, but it was like so much probing from the other kids for their thinking to go to like a different level. Even if they had the answer, it was like, how do you know? You know, like really having to explain it and justify it and say more about it.
Yeah, there was the how do you know, and it went by very fast, but one of my favorite parts is the teacher at the beginning said, you have your sentence starters. We were talking earlier about safety and things like that, and one of the sentence starters that you heard was, I disagree. But I don't know if you caught it in an early part student said, "You said it's 0.08 and I think that's wrong." And the girl next to him said, "You can't say that." And he went, "Oh, I disagree." Okay. Yes?
I'm struck by the last one, by the blonde girl who didn't say anything. And it makes me think that in the last model, a non-participating student could get a lot out of it without saying anything. So the way time passes in the last model versus the first model, where you feel, in the first example, you feel the teacher pushing, and time is, the clock is ticking, and he's anxious for an answer. But in the last group, there's not a sense of that time limit, and a non-participating student could get a lot out of that conversation, even if he or she wasn't speaking, because it's in that kind of small group, safe time zone.
Yeah, so I wrote time to engage, but part of your point is there are various forms of engagement too, not just getting answers and verbalizing. Yeah.
I was struck too by the body language of the students. In the first one, they're all kind of slouching and trying to pretend like they're writing, so they don't get called upon.
Yep.
Called upon was not a good thing. And then in the next one, they were sitting in little groups, and you saw a little more holding of the body forward, a little more engagement, especially as kids started going up to the overhead and explaining. All of a sudden, you saw a lot of kids sitting upright, getting more engaged. And then in the last one, I mean, they were just all over it. They were all forward, they were all engaged, nobody was pulling back. Yeah, you could just see it, the interest level rose.
Okay. Yes.
I'm going to go against the grain a little and say, especially in the era we live in now where kids are so kind of in like sensitive emotionally, that the videos became progressively scarier socially.
Okay. I want to abstract that because I chose the videos chronologically and they do represent the trend you talked about. I do not want them to be seen as a progression of from bad to good. Classes are very multidimensional things, and what I'm really using the tapes for is to raise a bunch of issues, and the issue is safety. The issue is comfort, consequences for what you say, what it takes to get brave enough to be able to say such things. So you went with my grain, thank you. You didn't go against the grain. I mean, that's that's the space that matters. One last chance, and then I'll reveal the man behind the curtain, who's me.
I just kind of want to add on to what you were saying there too, but there was a progression in those videos, but I think even today, the way that we're teaching today and what we do today, there's a time and a place for each one of those, even now. I mean, there's a time that the teacher needs to lead through the lesson. There's a time for each one of those in every lesson, I think.
Yeah, I think that's an important point. Again, we're not progressing to a particular model. There's no one right way to teach. The two most wonderful teachers I had were so different in so many ways. And there's no one model of how to teach. That's critically important. Okay, let me now explain what I was doing with this. If I'd given you some more time for this, but I want to finish with, I hope, enough time for you to see my favorite video. I'd have had lots more stuff on the board. I've done this loads and loads of times, and every time it turns out all I need is 5 columns, because the comments that people make always line up in those 5 columns. The first has to do with the very content the students were engaged with. We didn't talk much about that, except to say the first tape was about answer getting, and it was about very, very straightforward stuff. Not much room for thinking, not much room for mathematical connections. The second one showed different ways to work on the same thing and ultimately would get to how they're connected. So that was somewhat rich mathematically. And then the third one was about multiple representations, tying them together, arguing about arenas that we know are mathematically challenging. Oh, by the way, I'm a math guy and I had math tapes that were easily accessible. It's the same in science, it's the same in ELA, it's the same in history. You know, in some classes they memorize 1066, 1492, etc. And in other classes they talk about imperialism and what causes wars and other things. So the serious question here, the first dimension, if you will, is just how rich is the content that people are engaging with? And it's obviously critically important because the richness of the content that gets discussed sets an upper limit on what the kids are going to get out of that conversation. Okay. The second dimension has to do with how much the kids were being asked to stretch. Okay, how much were they being asked to think? And you know, this was taken from another time we did this when happily we had 5 scribes up and some of them had better handwriting than I did. You know, in the first one there were surface questions. In the second one, tasks allowed for student-to-student discussion. There were multiple representations which supported student discussion, which is really interesting. What are the handholds? Well, if there's only one way to do the problem, either you get it or you don't. If there's more than one way, then more kids can find their way in. Is the lesson making sense for the kids? What's the size of the mathematical chunk? Were some of the comments that people made. Okay, that's the issue of cognitive demand. It's a jargon term. The serious question is, do the students have opportunities for sense making and for what we call productive struggle? Okay. The third one, we didn't say much about, actually, except to say that some students were fearful, did their best to duck and cover. You know, other students, and in the last tape you saw lots of kids digging in. Equity is of fundamental importance. Equitable access is of fundamental importance. And the question is, what opportunities did the students have? Did every student have to dig into the content in meaningful ways? Okay. Which leads to a related issue and an extension of equitable access that I really want to get into, which is the notion of student agency, student identity. This was mentioned earlier in the opening comments, and it's vitally important. Do the students feel they can do the math? Are they willing to jump in? Do they have a sense of themselves as math people? For those of you who are math folks, I have an experience that relates. I don't think this particular one is quite as strong in science, but I'm sure there's an analog. You're at a party and someone says, "What do you do?" And you say, "I'm a math teacher." And they get this look on their face. And they go, "Oh, I gave up on math in 4th grade when they told me to turn the fraction upside down and multiply." You know, ours is not to reason why, just invert and multiply. Or I gave up when they told me a minus times a minus is a plus or something like that. You know, I was never good at math. And I really have to push myself to not say, would you be as proud of being illiterate? Well, where did they learn they weren't math people? In math class. So the very serious question of how do we create environments that provide opportunities for students to see themselves as mathematical thinkers and problem solvers, or scientific thinkers and problem solvers, or readers, or as writers who have something to say and can put it down. They get that in their classrooms. And it's a question of what kinds of opportunities classrooms provide. And, that's a sense of agency and authority and identity. When someone says, I'm not a science person, I never got that stuff. They're both reflecting the failure of their education and a sense of who they are. That's the matter of identity. And then finally, the last thing that comes up, in the first one, you had no idea what students thought or understood. Someone once defined lecture as the spray and pray method. You know, and actually this group came up with something very important that many people don't think of with regard to formative assessment, and that is that unless you're even more psychic than I am, knowing what's going on in the heads of all 30 of your students and addressing it is impossible. But you're not alone if the other students in the classroom are engaged actively with their peers. And then you've got 30 sets of people engaging constantly with the content. And that's a very important resource, and that's part of what formative assessment is about. Okay, so what I just summarized are the 5 dimensions of the true framework. Every time we've looked at any tapes, all the comments fit in those 5. They fit with the stuff I said I'd spare you, which was the research. Now I'll just show you the pretty graphic, which is the first thing that matters is the content. It's got to be rich, okay? And every single discipline has its version of what it means. You know, if it's the next generation science standards or the Common Core, or the various things for literacy, etc. Second, cognitive demand. The serious question there is whether students have the opportunity for sense-making and productive struggle. They're the ones who are building their own understandings, and that comes from working at it. I remember when I was a graduate student, I got my PhD in mathematics at Stanford, and I had a course in complex variables from Max Schiffer, who was the world's expert and a gorgeous lecturer. And I remember every day I would walk out going, it's beautiful. I understand everything. And then I couldn't do homework problem number 1. Okay, it's one thing for the content to be gorgeous and even so beautifully explained that you have the illusion of understanding. It's another thing for the classroom to be such that you engage in ways that you build that understanding. That's the issue of cognitive demand. Equitable access, the question is, does every student have the opportunity to engage in meaningful ways with the core content? And I know we talk about that a lot, but it's often honored in the breach, and various practices like tracking or ability grouping often undermine that in very serious ways. There was a study done a while ago that looked at reading groups in an elementary class. The group of high flyers was named the Eagles. I think The kids who had some trouble with reading were named the albatrosses, I'm not sure. And what would happen is the teacher would go to the Eagles and ask about plot, ask about motivation. What do you think was driving this character? The teacher would go to the, quote, low-performing group and help them sound out words. Well, guess what? There was a bigger difference in performance at the end of the year than there was at the beginning of the year because of opportunities. So we get that aspect of equitable access. Now, the interesting thing that I want to say about that is that sometimes you can make access more equitable by complexifying the content. If you give a problem that can only be done one way, then either you get it or you don't. You give a problem that might be looked at 3, 4, 5 different ways, not only do more kids have a way into it, but the conversation about how is your way related to that way and that way and that way actually enriches the content as well. So there's equitable access, but then the notionship of agency, ownership, and identity. And again, if someone does okay in math class and then says, I'm not a math person, and never thinks about using it for the rest of their lives, we've failed them. The serious question is, what opportunities do students have to build for themselves a sense of, I can do science, I can ask questions, I can come up with plausible ways to think about them. I can write. I can evaluate ideas critically, build on them. I think of myself as a thinker. I'm a learner. That's the issue of agency, ownership, and identity. And if you're going to make a classroom work, you better be hearing what the students have to say and adjusting in the moment. That's the issue of formative assessment. And again, the point is sometimes it's you and sometimes it's the students. The key points. Every framework I know says, do I like what the teacher is doing or not? The teacher is very important, but the student's more important. Okay, the key question is, what does the world look from the student point of view? And I'll point out that in true 4 of the 5 dimensions focus on the student's experience. And then the implementation part of that is, how do we focus on the student's experience to make instruction as rich as we possibly can? So, you came up with all of those things. You should recognize everything in it. It says what's important. There are no magic bullets. So, what's the point? Okay, here are 5. The first is the 5 true dimensions are what matter. If things go well along these 5, kids really will emerge from classrooms as powerful thinkers. If there are problems with any one of them, there are going to be problems. Okay. The second, I've already mentioned, there's a fundamental shift in perspective. The key question is not, do I like what the teacher's doing? It's, what's the experience from the student's point of view? When I get to part 2, which is much shorter than part 1, you'll be glad to know, I'll show you some tools and a website where you can get all the stuff that I've talked about. My very favorite slide in all of the materials comes from our observation guide, which says, look at the lesson from the student's point of view. With regard to the content, how will a student answer the question, what's the big idea? How does it connect to what I already know? With regard to cognitive demand, how long am I given to think and make sense of things? What happens when I get stuck? Am I invited to explain things or just give answers? Do I get to participate? Can I hide under the desk? What opportunities do I have to explain things How's what I say built on? How am I recognized as being capable and able to contribute? That's where agency and identity come from. And how's my thinking included in classroom discussions? Do things respond to my ideas and help me think more deeply? That's where formative assessment helps the individual student. 3, as you can tell from looking at me, I'm not Madeline Hunter. I don't tell you what to do. That's not the point. I mentioned earlier that the 2 best teachers that I remember had radically different styles. On the other hand, they both scored very high on all 5 dimensions of true. The thing is that the way true gets used is to say, these things matter, how can I get better at them? So whatever you're doing, I mean, I've been teaching for somewhere between 200 and 300 years, and I ask myself these questions, and they still help me think about what can I do better. So you can look at each dimension. In which ways can I make the math richer? Where am I providing opportunities for the students to do sense making? How am I making sure that every student can engage in meaningful, powerful ways? Where do they have opportunities to build on to get their ideas out there and build on them? And where am I hearing what they know so I can do something about it? Those are questions you can ask, whatever your teaching style. Next, true isn't a set of tools. The most important thing is to have it as a set of questions in the way that I just described, whether it's for you as an individual or far better as a member of a teacher learning community. The real action happens when teachers get together in such a way that you can open up your practice and say, hey, we're all in this game together. Let's see if we can work on these issues. And I'll say something more about that with the tools. Because although true isn't a set of tools, we have a bunch. There's a website. I'll show that as my last slide. That was 4. And 5, if you're a teacher, department chair, administrator, first time you hear about true, your reaction is, I've got 17 goddamn initiatives to do as is. What do I need number 18 for? Okay. There are a few that I know people in Marin are working on, thanks to Eileen. They're not in competition, because you can take those 5 questions I asked before and ask them about what you're doing. So how many of you know complex instruction? Okay, not enough to make the point I wanted to make. Okay. There are various programs that have you do something. Things about literacy, things about math. If you ask, do I have how can I make the prompts we're using for students and student engagement richer? If it's about academic language, how can I make sure we're dealing with substantial content as they're engaging with the language, and so on? That doesn't bend you, whatever you're doing, out of shape. It enriches it. Asking the question, I'm having my students do this. How can I make sure I hit the sweet spot of cognitive demand so my kids can engage in sense making? Doesn't bend your program out of shape, etc. And in fact, what's critically important is that true winds up being a language of discourse that you can use that enables you to think about these issues and communicate them with others, whichever program you're using. The deputy superintendent of Chicago, who was responsible for math instruction at the time, said to me, the wonderful thing now is that my first grade teachers can talk to my 8th grade teachers and to their principals because they have a common language. And they use that common language to think about the changes they want to make. And if you think that way, then everything is coherent instead of disconnected. Okay. Chicago has moved from doing true in math to now doing true in all content areas, which if you're an elementary teacher is wonderful, because instead of being schizophrenic and trying to switch hats when you move from reading time to math time, you've always dealt with the whole child, but now you have something that allows you to deal with it in a more coherent way. Okay, that's true in all senses of the pronunciation. Those of you who know our formative assessment lessons, FALs, they're pronounced by the Brits as FALs, which means we have true math and false math. We cover the entire territory. Okay. So the second question, which is serious, that's all theory. How do we make it happen in the real world? And what I'm going to do is tell you about some tools, and then I'll have to stop, but Eileen's here and I'll be back. And this is a many-year project, not something that I hope ends with a Thursday afternoon talk. So, first of all, we have these things called formative assessment lessons. The fractions conversation you saw in grade 6 was from one of the formative assessment lessons. And these things come as, there are 100 of them, they come as packages that include a lot of support for the teacher, not only the materials, but things like, we've tested these in hundreds of classrooms. We know what your kids are going to say. We know what the issues are. Here are some ways you can respond without giving the game away so that your kids can sort through the stuff better. That's what scaffolding is really about, not making life easier, but providing ways the kids can get into the substance. So there have been more than 7 million downloads of them. You saw a bit of it. I won't go through a list, but basically the content was really rich. You saw the kids engaged at a level that met them where they were. No materials can ever do the work of equity, access, agency. That's the hard work of the teacher in crafting the right climate. Okay, so there's no solution for that, but the right kind of materials make it easier if you're so inclined, because they provide various ways for kids to get in and opportunities for scaffolding. And finally, we call them formative assessment lessons because that's what they do. They make a big difference. Again, I could show you tons of evidence, but I'll just tell you a little story. We were funded by Gates to do this, and Gates trusts nobody. So without telling us, they sent a team into Kentucky to ask, did these things work? And what they did was they went around and they looked at school districts that didn't use them and school districts that did, that were matched for demographics and all that. And what they discovered was, this at first is mind-boggling, the districts that use them taught 4 to 6 of these lessons. They're 2 to 3 days each. So on average, they got about 12 days of instruction. And the kids in those classrooms gained 4.6 months of mathematics learning. What? The reason is that what the formative assessment lessons do is scaffold a new kind of teaching, the kind of teaching that supports students in engaging in the ways that you saw on that tape. And we have videos, some of my students were in classrooms where this happened, of a teacher teaching a regular lesson, formative assessment, then the day after. Then a month or 2 later, same sequence. After the first formative assessment lesson, the next day's lesson looked exactly like before. One day's experience being scaffolded in the new way of teaching isn't going to do much. The second one, there was a little bit more change. The teacher asked a few more open-ended questions. By the end of the year, after 5 of these lessons, the teacher was doing half as much telling and twice as much asking. That's what got the 4.6 months. And you can line up those changes with changes that would register on the true scale. Okay? So how can we help? We have a tool called the True Conversation Guide. And the question is, okay, I gave you the framing. For each of the questions, for each of the dimensions, you can turn it into a question you can use to think about your instruction. And then you can turn each of those into a question about what you're doing tomorrow. And then you can expand them. We call it problematizing. So this is what the True Conversation Guide looks like. It says, okay, take the last one. For formative assessment, here's what the dimension is about. And here are a whole bunch of questions you can ask yourself every day as you think about what's going on in your classroom. The one that I chose to expand is the dimension for agency, ownership, identity. And things to think about. Who generates the ideas that get discussed? What kind of ideas do students have the opportunity to generate and share? Who evaluates and/or responds to those ideas? How deeply do students get to explain their ideas? And so on. If you think about those before you teach, and you use them to open up your practice over time, that makes for the kinds of changes that serve your students. Okay, so that's the conversation guide. The observation guide, built originally by San Francisco for its coaches, because they said, look, we believe in this stuff. We want to have something that our coaches can use to go talk to teachers about after they observe. We also use the conversation guide both before and after observations, so they're not exclusive. And basically, the idea here is, let's talk about look-fors. On the left-hand side are the kinds of things we'd like to see students doing. On the right-hand side are the kinds of things teachers can do to support the students in that. Are we seeing those? What can we do to see more of them? So for agency, ownership, identity, each student takes ownership of the learning process in planning, monitoring, and reflecting on individual and collective work. Ask questions, make suggestions, supporting, analyzing, evaluating, applying and synthesizing mathematical ideas. Think of that third tape that we saw. And then what can the teacher be doing to support all that? As I said, that was built by and used in San Francisco. I like what they did a lot. I asked, can I steal it back with attribution? And Jim Ryan said, sure. Now, some tools that are on the way, because the serious question is, what do you do if you decide you want to pursue this? Well, we have a bunch of tools to help a TLC work together. The first is an introduction to True. Okay? You know what that looks like because I pretty much did it. Okay? Then, the question is, okay, you've decided you want to do that. How do you and your TLC get into it? Well, you can do the introduction to True, and then often can't do all 5 dimensions at once. It's too complicated. Turns out if you focus on any one, you wind up thinking about all 5. But what often happens is a TLC says, well, we've been working on equity, but we've sort of hit a roadblock. We don't know what the next steps are. We'd like to think about agency because that's obviously where equity goes. So here's what we do. We start with a packaged workshop that's safe because we have the videos, so nobody's at risk. And we say, okay, we'll tell you about True. You know about that. We know the general goals. let's start with some pretty simple definitions of agency, ownership, identity. And now we're going to look at some videos. We'll remind you of some tools. So there's the observation guide, the questions in the conversation guide. Here's how we ought to talk about videos. You've seen that slide. And then we actually watch a video. Now I've chosen the videos so that first one's pretty good. You see the kids engaged. You're pretty happy with it. Second one is the same teacher. It's a year later, he's even better. And you go, oh, I see how you could grow from 1 to 2, and now I see how you could keep growing. And we talk about these kinds of questions. And if we've done this once or twice, the community gets comfortable feeling, okay, it's not judgmental, it's addressing issues I have, and I can sidle up to one of the teachers and say, you willing to be next? What if we go into your classroom, videotape you, and we'll facilitate the conversation, but you're boss. We won't go anywhere you don't want us to go. And once we get to that point, the community takes it on its own, and other teachers volunteer, and they're working on collective problems or practice with a focus. And after 6 months or so, they tend to say, well, we've really got this, and we discovered that there's a sort of roadblock to agency, which is if the tasks aren't such that the kids can really make progress on them, then they're not going to build that much of a sense of agency. Maybe we should worry about cognitive demand. So there's a natural progression, and it comes from the learning community. So that's what we do, and it becomes a routine and it works. I just want to tell you briefly about one more tool. That's a bullseye. On the outside, there are practices that are okay, they're pretty common. You can look at your lesson plan and see, is that what I'm doing? Having students work the exercises from the text. Is there short wait time? And so on. The inner ones, oh, the students feel safe, and that means they can actually focus a bit. Oh, even closer to dead on, fellow students are positioned as resources. So let me think about what's going on in my classroom, or let an observer help me think about what's going on in the classroom. Let me just think about how to move my practices over time towards things that are closer to the bullseyes. And various learning communities, including Math for America in New York, have used this, analyzing videotapes of their own practice. And as soon as you've built the safe place where everybody says, this is where we can work on the problems we need to work on so that our students can get what we want, that's when you begin to make real progress. So, will these things help? I hope so. Tentative indications are that they are, and I know that at least they're focused on what counts, which is helping teacher learning communities get together and do what you're impassioned about, which is getting even better at what you do. I know I missed by 2 minutes. It's 5:32. I apologize for that. There are probably people who have to leave, so I should declare a formal stop. I'll hang around for a while and chat with anyone who would like to. And I hope you find this enticing enough so that we can continue to work on it. Thank you.